In the quiet space of the maintenance hangar behind the terminal, the matte gray metallic aircraft bodies lie still and yet are not the same.
Right here, slight anomaly on the seam.
Noted. The thermal imaging looked clear, but I'll flag this section for review.
It's like watching a machine. Every movement is exactly on schedule.
And the tolerances are well within the green zone. Though each aircraft has its own structure and purpose, in this space they are placed under the same standard. Differences in design do not change the subtle tension spreading through every step they take. People can easily see how aircraft differ, but it is harder to see how their responsibilities remain the same. A question quietly emerges in the still air: why different machines must follow the same level of safety and precision.
In that silence, the central question becomes clearer than ever.
In normal operation, each aircraft is designed to serve a specific and distinct purpose. Some are optimized for long-haul passenger transport, while others are simplified for shorter, more flexible routes. Internal systems are configured differently, from engines to electronics, all reflecting their intended use. The African-American male engineer reviews a data sheet where every line represents thousands of hours of research and testing. The female engineer compares results with technical standards, caring not about the type of aircraft, only whether it meets the standard.
Workers continue their tasks, repeating familiar actions, but never allowing themselves to be careless.
In ideal conditions, everything must operate smoothly, with no deviation and no surprise. This standardization creates a common foundation where all aircraft must follow the same principles. There is no exception for carelessness, and no space for subjectivity.
This uniform standard creates a system where differences exist only on the surface.
Yet this creates a question that cannot be ignored.
If each aircraft has a unique purpose, why are safety and precision not adjusted accordingly?
Why must a simpler aircraft face the same inspection pressure as a more complex one?
He pauses at a detail measured in fractions of a millimeter, yet still unacceptable.
They pause, recheck, then continue, as if time matters less than accuracy. The contradiction becomes clear: systems differ, but standards do not.
This raises a deeper question about responsibility in aviation. Do design differences truly matter under absolute safety demands?
Or do those differences demand even tighter control?
The answer does not lie in the shape or function of the aircraft, but in the consequences of error. A small deviation, regardless of aircraft type, can lead to irreversible consequences. Every number he checks is not just data, but the boundary between safety and risk. Precision is not a choice, it is a requirement.
Even the simplest tasks carry equal responsibility.
Design differences do not change the nature of risk. Safety and precision standards cannot be adjusted for different aircraft.
They must remain at the highest level because consequences do not distinguish aircraft types.
This is not rigidity, but a principle built from real experience.
That is why everything must be controlled with equal strictness.
Direct comparison reveals that design differences are only part of the story.
A simpler aircraft is not less dangerous when failure occurs.
A more complex aircraft does not allow any error to be ignored.
He moves from one aircraft to another, but his method remains unchanged.
She applies the same procedure regardless of the aircraft.
Workers repeat the same actions even when details differ.
Consistency in approach creates a reliable system.
Not because everything is the same, but because everything is controlled the same way.
Differences exist, but they do not change responsibility.
This creates a strong foundation for the entire system. The original question is no longer a doubt, but a clear principle.
No matter how different aircraft are, safety and precision responsibility remains unchanged.
He looks back at the entire process as a continuous chain.
Workers complete their tasks, yet no one feels fully relieved.
Because safety is not something achieved once and finished.
It is a continuous process that demands constant precision.
We need to ensure the timeline is accurate.
Exactly. Differences only create variety, not reduced responsibility.
Consistency in standards builds trust unseen by passengers. In the end, what matters is not what the aircraft is, but how safely it is insured.